We need to obtain the derivative of y with respect to x whenever y is given by a raised to the power of x, raised to the power of a raised to the power of x, and this goes on all the way up to infinity. So let's begin. We'll start with a given infinite function. So here we have y equals to a raised to the power of x. So clearly we again have a raised to the power of x as the power. So that means here we can raise it to y. So this means we have a raised to the power of x. X will be raised to the power of y. Fine. Now what we'll do, we'll take the natural log on both sides. So natural log of y will be equals to natural log of a raised to the power of x raised to the power of y. Now we'll use a property of logarithm that states that whenever we have log of a, this is raised to the power of b, this will be equals to b times log of a. So in that case, we have log of y equals to x raised to the power of y multiplied to log of a. Again, we will take the natural log on both sides, where we have log of log y equals to log of x raised to the power of y times log of a. Now we will use another property of logarithm that states that whenever we have log of a multiplied to b, this will be equals to log of a plus log of b. That means we have log of log y. This will be equals to log of x raised to the power of y added to log of log a. Now log of x raised to the power of y, we can use this particular property to get natural log of y, which will be equals to y multiplied to log of x plus log of log a. Now we will take the derivative on both sides with respect to x. We have ddx of log y, which will be equals to ddx of y log x plus ddx of log a. We are going to use the fact that whenever we have ddx of log of x, that's given by 1 over x. Now here in our case, we have log of log y, so that means we will get 1 over log of y. Now since we have a log of y instead of an x, we'll need to use the chain rule. We'll multiply it to derivative with respect to x of log of y, which will be equals to, so here we have to take the product rule. So this will be derivative of y with respect to x times log of x plus y multiplied to derivative with respect to x of log of x. Now we don't have to worry about the second term because here we have log of log a, which is a constant, and its derivative with respect to x will be simply 0. We have plus 0. Fine. Now let's finally compute the derivative. We have 1 over log of y multiplied to, so here we have derivative of log of y, so this will be 1 over y, but again using the chain rule we have to multiply to derivative of y with respect to x. This will be equals to derivative of y with respect to x times log of x plus y multiplied to derivative of log of x, which is 1 over x. So we'll transpose this term to the left hand side. So we have 1 over y times log of y minus log of x whole multiplied to derivative of y with respect to x equals to y over x. Combining the two terms within the parentheses, we have 1 minus y times log of x times log of y whole thing divided by y times log of y. This is multiplied to derivative of y with respect to x equals to y over x. Now finally, we can obtain the value of derivative of y with respect to x, which will be equals to, we have y squared times log of y whole thing divided by x multiplied to 1 minus y times log of x times log of y. So this is going to be the value of derivative of y with respect to x.